been collaborating for 9 years already. So it's been a long journey, Tanya, and it's good. So if anybody didn't know, we actually met up yesterday for coffee as I was passing through Windhoek. And yeah, of course, we've got a whole lot of plans and we've got a whole lot of really cool ideas. So part of the plan is this Python and introducing it to the robotics part as well. And so Tanya volunteered to do some sessions today, tomorrow, and then Thursday. And then if Tanya's not available on Friday, we can maybe just do a wrap-up session of the whole thing. But Tanya, over to you. We're really cool to hear what you have to say. And for everybody who's wondering what this is all about, we're actually we're busy constructing a MOOC portal for Python, Introduction to Python, and we will then be adding all these recordings there as well. All right. So Tanya, all over to you. And we are really keen to hear what you have to present to us. Thank you so much.
Yeah, well, thank you for inviting me, Patricia. Thank you everybody for joining. It's really kind of like a great pleasure to be in like this group of people, of very excited people again. And yeah, as Patricia said, so we're going to look into kind of like how to program the robots with Python. And for today, I just have kind of like a little bit of overview on everything you need to get started. And then tomorrow, I thought we'll look at Python programming for EV3 robots. As in, I brought my Riley rover, wasn't very creative in building anything else, but got a Riley rover here. And in the back, behind those glass windows, there's actually robotics going on. There are 3 teams practicing on first Lego League and the Superpower Challenge, and I'll grab one of their robots. They use the Spike Prime for the Thursday session. I'll be back here on Thursday. So let's see, I'll kind of like work my way through all the ins and outs of MS Teams, which I don't use that much anymore. I want you to think about one thing, as in, why would you want to program your robot in Python? And I'm not sure what's happening here. Can somebody say what you're seeing at the moment? Do you see my screen?
Yes, we can confirm. We see your screen.
Good. Then I just need to put this into, I feel like a really old professor who doesn't know the technology anymore. Gosh, this makes me feel like so outdated. Okay, so kind of like, yeah, Python for Lego robotics or Lego robots. And as I said, like today we'll do a little bit of introduction and look at what it takes to get started. And then maybe some of the programming concepts, or maybe not, but why Python? So I need to get the chat out. I want to hear from you guys. Why are you interested in programming the robot in Python? And I'm not going to continue until I get some answers. I can deal with silence.
Do you want it verbal communication or do you want it in the chat?
Why don't you just put it in the chat, then everybody can kind of like read up on it, and you don't need to worry like, oh, where do I unmute myself, and with everybody talking at the same time.
Okay, all right.
And I see there's somebody typing already, so get busy typing, please.
Oh, Angie.
Okay, we got a snake.
Nobody's going to add. Okay, there seems to be some movement there.
You can write it into the WhatsApp group too if the chat doesn't work for you. Okay, one more. with words, not just emojis.
I usually called Python a snake language because it was very interesting for me to program it. It was very interesting, to say the least.
Okay, so let's go back here. So let me tell you that I am relatively new to Python. I haven't really programmed Python for more than 2 years, and I was pushed into it by my university, that's Texas Tech University in the United States, deciding that in the first year of our engineering curriculum, we're going to teach Python, and we use Python to promote data science and critical computational thinking. So I just kind of like had to learn Python. And there were good comments a moment ago. It's for free. You hear about it all the time. You open YouTube, you open Facebook, whatever, and you cannot avoid it. I don't call it the snake language. I guess I would call it the chameleon language, because there are like so many different ways Python can look like and can hide that it's really kind of like cool to learn the different flavors of Python, but you can kind of like do a lot of things with it from, let's see. Like, well, why would you want to learn it? And it's kind of like, it's one step up from scratch. It's a text-based language, but it is beginner friendly compared to other languages. If you've heard of C or C++, that one needs much more structure and setup. It's versatile. There's Python for robotics, there's Python for data science, there's Python for artificial intelligence. You can do web design in Python. There really is, there is like an application for Python everywhere. You can program microcontrollers, you just name it. It's good on your resume. And that's particularly kind of like for the learners you're coaching. It's like if you can put on your resume or on your CV that you have some experience with Python, you're in a high demand and your incoming salary will be higher as if you still have to learn it. And well, there is a lot of support. There are like blogs about Python, there are YouTube videos. There are just like so many reasons on why you would want to kind of like get a little bit of a feeling for that snake programming language and what you can do with it. It's a good entry into kind of like if you wanted to learn other programming languages. The short answer, why Python? I think for me, and why Python with Lego robots, is because you can. As in, why not? Hey, we can, let's just go and do it. The other cool thing about Python is that Python really is free. You don't have to pay for a license, it's for free, and there are like really tons of resources available online where you can copy and paste, where you can think about what it does and just kind of like, get a feel for it. So my idea for my goal with this these kind of like introductory Python presentations is to get you started to where you can then kind of like, continue in Python, or at least like know where you need to look. We can't teach you like everything in a week, and you just need to come like, I hope you will be ready to, or feel like I want to explore more at the end of this presentation. Okay, so here's the what you need to have portion. You need to have a computer and a Lego robot. You can have, if you still have like the EV3 Lego robots, and I like doing Python with the EV3 Lego robots, in addition to your EV3 set, you need to have a micro SD card. That's kind of like this thingy up here. You need to install Visual Studio Code, and there's kind of like a little involving getting ready process, but that worked for me flawlessly when I tried it for the very first time. So, but there are kind of like, so this micro SD card, it must not be bigger than 32 gigabytes. And it should be like this A1 has something to do with how fast it is. And I don't see myself here anymore, but I have kind of like one here. They cost about 160 Namibian dollars or 160 rand. At least that's what I paid here. They might be less expensive in South Africa, but that's just kind of like what you need to have in addition to your Lego kit. And I'll talk you through like where to find stuff and what you need to install before you're ready to go. If you have the Spike Prime robot, then the Lego Education software app, the Spike app, actually supports Python, and you're ready to go. Now, with these two different setups, the Python also looks different. And you cannot simply take kind of like what you used on one of the platforms to make it work on the other platform, but you will have to make some adjustments. Okay, let's start with the slightly more involved process. I'll show you kind of like, well, the most important thing, this is kind of like your moment to take a screenshot. So do like 21st century note-taking, take a screenshot of this slide. You need to go to these instructions from pybricks.com, EV3 minus MicroPython, and then follow the instructions there. But basically, they walk you through how to install the MicroPython, as in like the small snake, the tiny snake, the micro snake on the micro SD card. They also talk you through, well, how to install Visual Studio Code. Visual Studio Code is kind of like your programming environment. It's the software that opens the window in which you then program or create your Python programs. And yeah, once you have all that ready, you still need to take that micro SD card and you need to put it into your robot. I'll show it to you in a moment, and then connect your EV3 brick to the computer via USB cable, the same way as if you use the Lego software. And if you don't like the USB cable, you can use Bluetooth, Wi-Fi, whatever. I feel like for me, the USB cable is still the most reliable option to go. Everything else causes me more headache than I feel happy with. Okay, so I've opened, I'll change screens here. I've opened somewhere. Nope. Join conversation here. So when I said open this link, what you're getting is you're getting to a page that looks like this. And it has like the Lego Education logo on the top. And it's also kind of like your user guide that gets you along all the different sample programs and yeah, kind of like the look up how to use the command and so forth. So in the getting started section, they talk about the installation, they talk about what to do with the EV3 brick and how to create and run a program. So if you start kind of like from the top with getting started and work your way through, well, this is kind of like what I told you. You need a computer. You need to have at least Windows 10 or Mac OS computer. I don't think it runs on a tablet, but also I've never really tried it. At the beginning, in order to set up everything, you need internet access. You need this micro SD card that you can hopefully see here right now in the Tiny Tanya window. And you need to have a micro SD. Yes, you need to connect kind of like that micro SD card to your computer. So how does that look like? For me, that had several steps. When I bought the micro SD card, it came with an adapter, and somebody gives me like, so here's an adapter. You put your micro SD card in the adapter, and then I don't have a slot on my computer to kind of like insert this SD card into my computer. If you have one, you can just insert it. So I needed an additional adapter, as in this one, that has USB on one end, so I can connect it to my computer, and it has a slot other direction for the micro SD card with the adapter on the other side. And then you had to connect this to your computer. And this is kind of like the one time only. If you plan on having more than one robot with running Python, then you need one micro SD card for each robot. So I have a little Ziploc bag. All my SD cards are in there and they all have this micro Python on it. So basically when we create our program on the computer, the Python is then run directly on this. It's on this SD card and it's run on the Lego brain. Okay, so once you have your micro SD card connected with the computer, well, it tells you preparing your micro SD card, tells you like you need to download. Let's see, reader connected. Yep, you need to prepare your computer. You need to download Visual Studio Code. That's for the computer part. So when you click the link, it takes you to, and it's important, it's Visual Studio Code. It's not Visual Studio by itself, which also exists, but it's Visual Studio Code. And you need to download the Visual Studio Code installer for your operating system, whether you have Windows or a Mac or run some Linux on your computer. Once you've done that, you get like this little icon down here where it says Visual Studio Code. And it opens kind of like this. And then you need to still install inside that Visual Studio Code this Lego app. So you kind of like go to extensions here and then you search you just search for Lego. Let's see, and then you find the familiar looking one as in the Lego Mindstorms EV3 MicroPython version 2.01. I already have it installed on mine, but you click on it and then you press, you would press install here. I can't install it right now because it's already installed. I can uninstall it, but you press install here and then your Visual Studio Code, like this window, this editor is ready to go. If I remove my search here, so you see here under installed, I have, there it is. I have like the Lego Mindstorms, MicroPython, and it installed this EV3 dev browser in addition. What it also does is it creates here, it's kind of like hidden, but it creates this little button icon. Remember like our buttons here from our EV3, like that icon that relates to the Lego robotics. And then you can create a new project. You can explore example projects. So they are kind of like, as always, example projects. It also gets you to open user guide. When I click that, I'm back kind of like here in my user guide. Okay, so my computer is ready to go. I can open a new project in a moment. But what else do I need? I need to do something with this micro SD card. And that one was a little daunting to me and I'd never done it before. But you need to kind of like, in short, load the MicroPython onto the SD card, such that the SD card speaks Python. What it takes is, first of all, be able to connect your SD card to your computer. If you have like a micro SD slot, that's the easiest, but just kind of like connect it. Then you need to find, you need to download, that EV3 MicroPython micro SD card image. So that is basically a zip file. So you're downloading this zip file and make sure you do not unzip it. Keep it as a zip file. And then you also need to download what's called a card flashing tool. You need to download like a piece of software. And there's a link here that you can use as an Edger. And that software then installs kind of like this image file onto the SD card such that it's afterwards on your SD card. Also, all the Python projects that you're going to write will, like when they are executed, the Python interpretation will run from the SD card. Okay, so this is kind of like select the image. So you would select like this file, you select the drive that is, you make sure you flash it to the SD card, and then you say flash, and then it's busy for a while, and then it says success. And then you have your MicroPython on your SD card, and you can disconnect your micro SD card from the computer, and you don't have to worry about that process at all anymore. As I said, if you, like me, want to do an entire kind of like set, like I have 7 micro SD cards, and it took me like 3 stores to find them. But just do all of them at the same time. Maybe try the first one and see if it works, but then kind of like do it with all of them, be done with it. You're good from now on. Okay. If you have a micro SD card, maybe from one of your Android phones, you can use that one. Just make sure or be aware of the fact that when you flash the image onto it, whatever was on your micro SD card beforehand is gone. Okay, last step on this is, well, insert the micro SD card into your EV3 brick. And something I really loved is kind of like this here. You can add tab wrapper, and I've kind of like, well, I didn't bring everything I needed. Like I didn't have like a clear tape, but I had like duct tape, since my husband always brings kind of like a toolkit with him. So I took a little bit of duct tape and I added kind of like this flappy tail to it, such that it's very easy to insert the SD card into the robot. Just push it in all the way. But unless you have like this portion here that sticks out, you need tweezers to get them out. I watched some YouTube videos. They didn't talk about this, but yeah, basically they said like, yeah, get some tweezers. It's a pain in the butt to get the SD card out. Without it, here I can just kind of like pull it out and it's gone. So what happens if I put the micro SD card in? If I put the micro SD card in all the way and I start the robot the way I always start the robot, as in center button, then let's see what happens. If it makes the noise that it typically makes, then I didn't push it in all the way. It didn't make the noise. Well, I can't see anything on the screen. I'll hold it here close to you, but they're like flashy LED lights in orange. There's a whole bunch of kind of like text going through the display. And once it's ready, the green light should go on as always. And we're ready to program. In the meantime, I'll connect my USB cable to my Riley rover here. I'll put it to the side. It takes at least as long as the startup procedure with the normal EV3. And you just leave it on the side and you give it time. While it's starting up, let me just say the shutdown process is just the same as the shutdown process normally is. You would take the little back button and press it. Then you would kind of like in the menu with left, right, select the shutdown. You shut down, and again, like a lot of text goes across the display and the LEDs flash, and eventually all the lights are off and the robot is off. Now, if next, or like, how do you get your robot back to, I didn't like this now, how do I get it back to working the normal way with the normal Lego education software? All you need to do is wait until the brick has shut down. And after the brick has shut down, pull out the SD card, and everything is as if it had never happened. Okay, so Hey, I'm happy. I got some green lights. So I do have some green lights here, and my robot is ready to be programmed in Python. And since we went through all this lengthy process of, getting the robot ready, or like the environment ready, I'll show you what the environment now looks like. So, but we basically made it kind of like through the instructions here. They've taken some nice pictures on what the display looks like. So you can kind of like look at, well, you have the main menu, you have the back button here, as always. When you press it, then you can select power off. And then you can also kind of like view and monitor like sensor values the same way you can do it normally with the Lego software on the brick. And you can run programs without your computer once you've downloaded them to the EV3 brick. And here they just kind of like say what you need to do to go back to the original firmware, as in switch it off, pull out the SD card, switch it on again. Okay, creating programs. Well, let me go back to this dude here. So here is, remember, this was Visual Studio Plus, Visual Studio Code. And here I'm in kind of like the menu. I can check create new project. And up here, a window pops up and I need to enter a name to my project. My demo project. Press enter. I need to decide where I want to save it. Let's create an iSet folder underneath UNISA. And I say select folder. Okay, and now it looks like this, pretty boring. What's next? You see, like we have open editors here. We have kind of like a .vs Code portion. You don't need to worry about this. There's something .git ignore. We don't need to worry about this. We need to click on main.py, where py stands for, it's kind of like the extension for Python files. All the Python files have kind of like a .py. And when you click on it, text shows up. Okay, now let me, with Command plus, I can make the text larger. Can also kind of like move this little over. And this is what you get. And here we have what a Python file looks like. It's basically text in different colors. And yep, and we'll get to run it in a moment, but let's look at the different things we see. Now, the numbers here on the left, they're just kind of like the lines of code. First line, second line, third line. So basically, the program gets interpreted from the top to the bottom, line by line. And we'll later see how we can jump from the bottom back further up to the top. Everything that shows up in green is a comment. So a comment is something that is, well, apart from like here on the top, that one tells the computer to use the MicroPython that is on my robot. But like all these line 11, 12, like these hashtag commands, this program requires Lego EV3 MicroPython 2.0 or higher. Click Open User Guide to learn how to get it, create objects, write your program here. So all the green stuff that starts with a hashtag, it's a comment, and comments are there just for us, as in the people who operate the computer. So we should put some instructions for the next one who reads the file, or for us to better remember, into this program, as in what the heck was it that last year I tried to accomplish with this program. Okay, so that's the green stuff. For on the robot, it doesn't do anything at all. And then on the top, we have like all these lines that start with from, and then from PyBricks something, import something else. So all this is specific to the MicroPython that is on this EV3 robot. That's why like Python for EV3s looks different from Python on the Spike Primes, and it looks different from Python and Python for data science. So the chameleon Python that does whatever you need it to do. So we want to program a robot, and our robot typically has it has an EV3 brick. Well, a minimum robot has like it needs to have that EV3 brick. So the Python needs to recognize that there is the brick. The brick has what? It has a display, it has buttons, it has lights, it has a speaker. So kind of like all those we need to be able to access and to program. So somebody has done a whole lot of work for us already behind the scenes, and we don't get to see it, on making it easy for us to program this Lego robot, this EV3 brick in Python. So when we open this new project, everything here that we might need gets kind of like imported. These are called like libraries, and in the libraries there are classes. So they're kind of like the different hubs. They are EV3 devices. So like using motors, touch sensor, color sensor, infrared sensor, ultrasonic sensor, and the gyro sensor. We need to import the ports. Remember, it's important, like my motor, to which port is it connected? We need to define a direction for the motors, like pressing buttons, color, and so forth. Now we have certain tools. And you know some of those already come, like you can wait for something to happen. You can have a stopwatch. You can start some data logging. And then we have tools that are specific for robotics. And like for robotics, what we're importing is kind of like the drive base. So with drive base, what somebody has already programmed for us is the idea that nearly all the robots that we're building have something in common, regardless of whether it's the Steve bot, the Riley rover, the Lego educator. What they all generally have in common is that they have two motors driving the wheels. So they're like the two motors in parallel that drive the wheels. And if we want the robot to go forward, both motors need to move. If we want it to go straight, they need to move like at the same speed for the same number of rotations. So that's all hidden kind of like behind the scene in like this drive base, to where we can then use it and just say, hey, go straight for such and such. So and so many rotations. And it'll automatically tell that to both of the motors that drive the wheels. Okay, and then we can also import sound or image files if we want to have stuff being shown on the display, or we want the robot to speak and make sound. Okay, so all this is kind of like specific for our EV3 robots. Just keep it. It does stuff. It's kind of like doing good things for you. And then we are starting with the programming afterwards. So now the big question is kind of like, hey, how the heck do I know what I can do? Well, you can first of all, you can already run or kind of like try to run this program and see what happens. And then you need to go back. You kind of like escape. Come on. I don't want to get out of present here. I want to get out of the full screen. Doesn't want to. Oh, this is embarrassing. My full screen doesn't disappear. Let's go back here for a sec. Maybe like see. Now I can stop the full screen. I'm not going to do that again. And we're going to close this. Okay. So far, so good. We'll try again. I'll get that Visual Studio Code up. Make it a little smaller and get my Safari up again with the user guide and share the screen again. Let's see, where's my screen share? Now my screen share has disappeared. Yeah, share.
See, the network is taking its time today.
Yeah, I also noticed that. There we go. There we go.
Okay, it's not the network, it's user. It's the user. It's the user
Okay.
that's so slow. Okay. Good, but now I have like my Visual Studio Code up here. Looks like I killed what I've created beforehand because it's not there, so I can show you in the meantime. So this was kind of like the create a new project. How do I find my project if I accidentally closed it? So we're going back to Visual Studio Code. And we go File, Open Folder. And this is different from like other Python programs. You need to open the entire folder where you stored your project, not just the file. And let's see, Documents, UNISA, I said. And my demo project, here it is. So once you have the folder, you say Open, and then the project is back. And now the question is, what does it do? How do I run it? How do I learn what I can do? So that's where we stopped. How do I learn what I can do? That's what you have the user manual here on the left for. So you go back to Open User Guide. And then you have your user guide, and I'll make this a little smaller. And then in the user guide, it has like all the different kind of like a description of all the different modules. Like here's our hub. That's what the hub looks like. We can press buttons. We can switch lights on. We can switch lights off and so forth. So it guides you through EV3 devices. Here are like the 3 different types of motors we have. So kind of like Python is a programming language that is object-oriented, so it puts everything into classes with different properties, and robotics is a really good way to see like why do we need classes. So there is a class in what we imported that's called motor, and what it does is it provides all the functionality that a motor can have, and motors can do different things than the brain, the EV3 brick. They can do different things from a touch sensor. Basically, what a motor can do is it can turn. So that's really like all it does. It can turn in one direction. It can turn in the other direction. And it can turn slow. It can turn fast. And the motor has a connection at the back through which we can connect the motor with the EV3 brick, and the software needs to know to which of the ports A, B, C, D the motor is connected. Same as with the Lego firmware or the Lego software, the Scratch type of software you're typically using. And yep, that's all the software knows about the motor. The software does not know whether this motor turns an L-beam, whether it turns a wheel, whether it's a wrench and it pulls up an item, whether it operates an attachment. None of that is of interest to the software. All that is kind of like hardware. All that is hardware design. What do you make the robot do? How do you build your robot from the Lego components? What the software knows is I have one motor that is connected to port C and I want to turn it forward or reverse, or and at whatever speed. So with our class motor, we need to say to what port it is connected. We need to define kind of like a positive direction. And that is, so what's positive direction? Well, I need to hold the motor exactly the way it's shown on the picture. And then positive, if I say direction clockwise, then, well, this would be a positive number for the direction or the speed. And this would be reverse. And then we can also tell it whether we have gears connected to our motor. And yeah, so every kind of like component or a device has, well, we have touch sensors. They can do, well, they know whether they're pressed or not. We have color sensors. A color sensor picks up either like a light intensity or it picks up a color. So they all kind of like belong to different, each of them is a class by itself with a capability of its own, because they can do different things. Okay, but we'll see more about like how to set the motors and everything up next time. What I still want to do is, if I go here where the play button is, I hope I can press download and run. It probably will tell me that I first no EV3 device is connected. Should be connected. Here, connect now. So which one? It's kind of like searching for devices. It suggests that my EV3 device is called EV3 Dev N7. Okay, I've selected it. And it says download complete. So actually, since I pressed download, it connected it. It completed the download. There was this window that shows up. So let's just make this disappear. Let's do it again. I went here on the triangle, run and debug. I press download. Now the robot is still connected. So when I press download, it downloads this program onto the EV3 brick. It shows a new window here. And the EV3 brick beeped to say, hey, mission accomplished, program successfully downloaded. Here, this is kind of like our output window. So all it tells us is kind of like it's downloading the program. The program was called My Demo Project. And it goes into a certain folder on the robot, home/robot, My Demo Project. And the file here was the main.py. And then it says completed successfully. So that's cool. Can also kind of like make this small again. Then I see more. Why did it beep? It beeped because here I told it to beep. So what this kind of like, all I said was like open new project. And what it does is here, it creates an object called EV3 that is of class EV3 brick. So it's kind of like initializing the EV3 brick, saying for this project to run, or this program to run, we need to have an EV3 brick. And we need to give this EV3 brick a name. So at the moment it's called EV3. Probably everybody will call it EV3. I can call it Tanya's EV3. So on the left, you're free to name it whatever way you want it. On the right, you need to pick the spelling exactly as it is here. And then the empty brackets are important, but there's nothing in there because we don't need to tell the EV3 brick anything. It's just kind of like, but you need to have them. So now if I do it this way, it's Tanya's EV3 that's sitting on my table here next to me. Note that I didn't use an apostrophe here. So I said you can write anything here, anything that consists of letters, underscores, and numbers. And it must not start with a number. So letters, underscore, more letters, and then a number. Okay, and now if I want my EV3 to make a noise, as in to beep, then we need to give it the same name. So now it's always Tanya's EV3. So Tanya's EV3. Now Python has a lot of this dot notation. So it's kind of like you're calling, well, in computer science language, it's called a method and or an attribute. So what this does is it says, well, program, find Tanya's EV3 brick. Here it is. Tanya's EV3 brick has a speaker. So dot speaker says like as part of this or component of this Tanya's EV3, there is a speaker. And that speaker has a functionality as in it can beep. And if we use again like the empty brackets, it beeps with a default beep. So somebody has taken care already of the, how should it beep? How long, which beep? We can specify if we don't like the beep, we can specify it here, but we'll do that next time. So I can now download, well, also come like you see here, when we have like a black circle, then the program hasn't been saved. Control S is always the shortcut to save your program, and then you can download it. It downloads it again, and it beeped again. And how to make it beep differently, that's what I'm going to tell you tomorrow. Okay, and then you can leave all this before you leave the EV3, like the Visual Studio Code. Make sure you have an X here in the main.py. Then otherwise Control S, save your program, or file save to save your program, and then everything is good and you can just kind of like get out of it and be done with it. So that was all you need to do on the EV3 to start programming in Python. Now, what do you need to do with the Spike app? You need to have like the Lego Spike app installed on your computer. You double click on it. You give it a moment. I'm having a Spike Prime, although I'm not having a Spike Prime. It's sitting behind me. It's not available here right now for me. So nothing will work. I cannot demonstrate anything to you. But you can just say new project. And then you can say Python here. So select Python, say create. And now we have the programming environment in Python. Let me see, not everything that works in my other one. No, I cannot make the font bigger. Sorry, we're stuck with the font size. Unless I figure out until tomorrow how to do this, or until Thursday, because we're doing more here on Thursday. So what you see is kind of like, again, like different colors. We have again like this from import something. So now we're importing from Spike and importing the hub. We're importing the light matrix. There are buttons, there's a status light, there's a force sensor, a motion sensor, a speaker, a color sensor. There's an app, a distance sensor, motors, motor pair is kind of like for driving the robot. We're importing then some control, as in wait 4 seconds, wait until, and a timer. We're importing some math, although we don't need to. And then we're setting now again like, well, to have that yellow spike brick or like the hub. So this is hub. So we need to tell it, hey, there's a prime hub, a spike prime hub. And then by default, what it does is on that hub, there's that light matrix. So again, you can make a Tanya's hub on the left. Name it whatever way you want to. On the right, use exactly the spelling that you find up here where it says import. So Tanya's hub has a light matrix and it can show by the image happy. And I could now, kind of like now I would have to say connect. And I don't have a Spike Prime hub here right now, so I cannot connect anything, but I would press on connect and it would connect via USB cable my Spike Prime hub. And I can then download, or if I can use the play button, and it'll download and play the program, and it will show up as program 0. I can also kind of like, if I don't want it to be program 0, here we go. So I can select, do I want it to be program 0, program 1, program 2, and then download it into, I think there are like 6 different programs on the Spike Prime Hub that you can download. All your user manual, go away. All your user manual is here in this pop-up thingy. So it's kind of like you can make it disappear, you can make it show up. It has a getting started menu, and you can really kind of like work writing a Python program. Yeah, so the minimum we need is kind of like from Spike import the Spike Prime Hub, and normally we have a motor pair, and then it tells you, it always has like little snippets of what you can do. And if you click here on the copy, you can copy and paste the sample programs into your editor, and then you can run it. Talks about comments. Comments again show up in green with a hashtag. Initialize the prime brick or hub, stuff like that. And it works kind of like when you're done with that one, you can kind of like, you can always go back and you can look at kind of how do I control the motors? How do I do something with the motors? How do I initialize the motors? We'll see all those details on Thursday on the Prime, on this like Spike Prime app. In the console on the bottom here, that's where it will give you error messages. Unless you copy and paste and don't do anything yourself, code never ever works immediately. Read those error messages. It takes, they're doing a good job in telling you what went wrong, and try to find your way from there, as in why went something wrong. I guess maybe if I do plus here, here we go. I've learned today how to make this larger. So here's larger font. Yeah, so very intuitive. There is like the little home back here. If, as you say, my projects, or like go back home. When you select new project, the Python doesn't show up, then you need to go to settings, general, and make sure enable Python projects here is enabled, such that you can then use Python projects. Okay, now I filled my entire 1 hour. Let me stop the share screen. Let me get everybody back. Are you still with me?
Okay. We are right here. We are right here.
We are right here. You all have been, nobody has put anything into the chat. I hope this wasn't too overwhelming. Let me write my email address into the chat. Reach out if it doesn't work.
We all just need to start.
You just need to start doing it. It is, I keep saying, computer programming is like athletics. You don't learn to play basketball by watching a basketball game on your TV, sitting on the couch and drinking a beer. You can appreciate basketball as a game and how great the athletes are by watching it. But you'll never learn programming solely by watching somebody else doing it. You just need to start. And the same way as when I go to the basketball court and start throwing the basketball into the hoop and it won't work and I look like an idiot, the same way your first programming experience will be very rudimentary. It will not look like the NBA and like a professional basketball player. And it will not work immediately, and you just keep going and doing and doing and doing. And somebody once mentioned there's like a 10,000 hour rule, like after 10,000 hours of doing something, you're getting really good at it, whether it's playing an instrument or programming a computer. And you don't have to spend 10,000 hours on it, but just don't expect, kind of like scale down your expectations, be happy with little progress, and it'll all be fine. And it's a journey to take. Also, keep in mind when you do that with your learners, it's okay to say, I don't know the answer, we'll figure it out together.
Very important. Absolutely. Absolutely. Got to be very patient with the learners because they have to be patient with you as the coach as well.
Yeah. So then tomorrow, I will join you from Namibia University of Science and Technology. Usually during the day, our internet is crap because we have like 16,000 students on campus and they all want to use the Wi-Fi. I hope it will work out. We'll make the best out of it. Tomorrow, we're going to talk about the EV3s and programming them in Python only, assuming that we have our robot, we have our SD card in it. And now how can I make it do stuff?
Okay.
On Thursday, we'll do the same thing again or like similar things for the Spike Prime. So if you're only interested in one or the other platform, you don't need to be here or like you don't need to join us both days. You're of course welcome to do so. And yeah, on Wednesday, unfortunately, I need to teach until 5 o'clock. So no Wednesday class and I'm traveling on Friday. But I think it'll give us a start and then we can take it from there and see like what questions, what follow-up desires on your end are there as in next, could we please? But I have some cool projects to demonstrate tomorrow. Yes. Hopefully the internet is with us.
We hope so. We live in hope.
And you don't have any load shedding.
Oh. Thank you, Tanya. Thank you so much. Yes, now we all need to go and do likewise. Thanks for the good questions. And there were some comments, but I think you've answered all the questions. Oh, that was right at the beginning. That's when we had to give comments. So thanks, Eric, for your input. The bottom left, plus sign.
Yeah, the plus sign. I found it without seeing the comment, but I found it.
You see, we live in a world of eternal learning. So thank you for that. We will then see everybody tomorrow. And just for kind of a FYI, these recordings, Tanya and I are busy creating a MOOC portal, which is called Introduction to Robotics in Python. And yeah, the plan was to upload the content last week, but that didn't happen. But it'll be in the kind of in the run of this week. We'll start adding the content and putting everything in place, and then inviting all of you to kind of evaluate and see what we're up to, and maybe your comments and evaluation is appreciated. All right. So thank you, everybody. Thank you, Tanya. We will see you again.
My pleasure.
Tomorrow.
See you all tomorrow.
Same place, same time. Thank you, everybody. Thank you for joining. Thank you, Casper, for doing the recordings. And we will see you then tomorrow. All right.
Sounds great. Take care, everybody. Have a great evening.